Hey guys, these are going to be selected answers to homework number 7. So this is going to be good review for the quiz, the upcoming quiz. So we're going to start with number 25. For number 25, we just apply our rules. We remember our study guide. Here it is. It's going to be the property of equality for logs. Meaning if we have the same log on both sides, we can go ahead and kind of cancel them out. And then y or x has to equal y. So if this, then this applies. So let's go back to our problem. Here we notice that log or natural log is on both sides of my equal signs. Remember that natural log is a log base e operation, log base e. So really what I can do is just kind of forget that the log is even there or the natural log is there, and I can rewrite this as 4x minus 7 is equal to x plus 11. When I rewrite this equation, this then kind of becomes like a two-step or solving a two-step equation. We go ahead and add 7 to both sides. We add 7. This goes away. We're left with 4x is equal to x plus 18. We subtract an x to both sides. This goes away. We get 3x is equal to 18. We divide by 3 to both sides, and we get 6. So that would be number 25, and that's kind of the easiest way to solve that. So if you guys need to look at that again, please make sure to rewind this part of the video or slow it down as needed. I'm going to jump to the next requested question. You guys asked for 35. So here's 35. Again, we're going to have to solve. This one is a bit tricky. So let me pick blue. We want to get log by itself before we can do anything, because we want to solve for x. Before we can even exponentiate this equation, we have to get rid of the 5.2. So if we divide both sides by 5.2, which you do to one side, you have to do to the other side. This goes away. I'm left with log base 4 of 2x is equal to, well, we can leave it as a fraction, or we can make our lives easier by just punching this into our calculator. When we do this, we end up with 3 or approximation of 3.08. Now I want to get rid of this log base 4. Well, what gets rid of a log base 4? It's an exponent with base 4, or an exponential number with base 4. So I'm going to exponentiate this entire number, meaning I'm going to rewrite it as my exponent to the base 4. Here we go, base 4, 2x. This is equal, what you do to one side, you have to do to the other side, 0.08. These bases go away, and we're left with 2x is equal to, this is a bigger number, so when we punch this into our calculator, we get an approximation of 71.5. Then I just solve by dividing both sides by 2. I divide this by 2. I get that x is an approximation. We punch that into our calculator. We get 35.8, or an approximation. And that is your answer for that one. So that's number 35. Moving on to the third question. We get number 39 from your homework, number 39. So before we can even get rid of the natural log, we're going to go ahead and group these two terms together. Now this is one of the properties that we also covered. This is actually the product property. If we're adding two logs of the same base, we can go ahead and combine and multiply their values. So let's go ahead and do so. So here we have that the bases are both natural logs, or they're both base e. When we combine them, we can combine them as natural log of x times x plus 3, and that's just equal to 1. Well, if we distribute this x to both our terms, we end up with natural log of x squared plus 3x is equal to 1. We can cancel out the natural log by exponentiating this whole thing with a base e. So we know that e will cancel out our base e, or our natural log. So if we rewrite this to show the steps, we end up that what we do one side, we have to do to the other side. We do the first. This goes away. We're left with x squared plus 3x is equal to e to the first power. What we notice here is that this is a squared term, so that if we subtract e to the first power from both sides, we actually get x squared plus 3x minus e to the first power is equal to 0. We can then apply the quadratic formula and figure out the solutions to this. So if we say a is 1, b is 3, and c is equal to negative e, we can actually set this quadratic formula up, and then you guys can punch it into your calculator and obtain two answers. We have x is equal to negative 3 plus or minus the square root of b squared, which is 9, minus 4ac. A is 1. C is going to be negative e all over 2 times 1. This reduces to negative 3 plus or minus the square root of 9 plus 4e all over 2. Now I'm going to go ahead and punch in the discriminant in my calculator and take the square root of all that good stuff and see what I come up, and maybe I can reduce that a little bit more for you guys. So I get the square root of 9 plus 4 times e to the first. Great. So I actually end up, once I punch those values into my calculator, with x is equal to negative 3 plus or minus 4.46 over 2, which means I'm going to have two values. X is going to equal negative 3 plus 4.46 over 2, or x is going to equal negative 3 minus 4.46 over 2. Now, if we notice that this term, if we're subtracting two negatives, we can just go ahead and add the negative or add the inverse. This is going to give us a large negative number. We can never have a negative number as our solution for logs. So this is our extraneous solution, meaning whatever we get here will be our true solution. It's an approximation, so if we were to plug it back into our original function, we actually get a pretty close value to 1. Let's look at the next one. For number 42, we're going to apply pretty much the same kind of mentality or the same strategy as before. We notice that these two are base 6 numbers. If they're base 6 numbers, we can go ahead and combine because of our product property. So let's go ahead and combine these two log base 6 numbers into one. So here's log base 6 of 3x times x minus 1. And that is just going to be equal to 3. When I distribute this 3x to these two terms, I actually get log base 6 of 3x squared minus 3x is equal to 3. To get rid of this, we want to get rid of this log base 6. So what gets rid of a log base 6? Well, an exponential number with a base 6. So we're going to exponentiate this entire quantity. So we get 6 to the log base 6 of 3x squared minus 3x. What you do to one side, we have to do to the other side. At this point, these bases cancel out, and we're just left with 3x squared minus 3x is equal to, and if I punch that into my calculator, I get 6 to the third power is 216. Again, I notice that it has this squared term, so I'm going to subtract 216 from both sides. I get 3x squared minus 3x minus 216 is equal to 0. I want to set it equal to 0 to see if I can factor this thing out. I also notice that it can be divisible by 3. This whole quadratic can be divisible by 3, or you can factor out a 3. If you divide this entire quantity by 3, what you do to one side, you have to do to the other side. So let's go ahead and divide everything by 3. This goes away, I get a negative, and this reduces to a 72. So this goes away and I get a 72. If I clean this up a bit and follow my expression, I'm left with x squared minus x minus 72 is equal to 0. This then becomes easily factorable. We can do the cross method if you guys would like, or whichever factoring method you prefer. We notice we're going to have the factors of negative 72. When I add, gives me negative 1. This is going to be negative 9 and 8. So if I were to factor this out, I get negative 9 plus 8 is equal to 0. If we apply the zero product property rule, we know that we must get a solution for both of these since we're multiplying and it's set equal to 0. X will give me a positive 9 and negative 8. One of these answers is extraneous. It will be the negative 8 because we can't have a negative solution for logs. It just doesn't exist in our domain. So that's number 42, meaning this will be our true answer. Number 44 in our assignment, here we go. We want to go ahead and solve again for x. So now we're going to try to isolate this log function as much as possible. What I do first then is get rid of this 8, or subtract 8 from both sides. This goes away. I reduce this to log base 8 of 2x plus 7 is equal to 2. I then divide this by 3, which you do to one side, you do to the other. This goes away. I'm left with my log base 8 of 2x plus 7 is equal to 2/3. Once I have that down, I can go ahead and cancel out my log base 8. What cancels out a log base 8? Well, it's going to be an exponential number with a base 8. So I'm going to exponentiate this entire quantity. So I get 8 to the log base 8 of 2x plus 7. What you do to one side, you have to do to the other side. So my term is 2/3. There we go. This goes away. I'm left with 2x plus 7 is equal to, well, if you want, at this point, we can go ahead again and use our calculator to kind of simplify or estimate that value. So 8 to the 2/3 power gives us 4. That worked out nicely. We subtract 7 to both sides. This goes away. We're left with 2x is equal to 4. Negative 3. There we go. We divide both sides by 2. Divide both sides by 2. We're simply left with the answer of x is equal to negative 3/2. And that's our answer. Now, if we were to plug this in to our original log value, we notice that the 2's will cancel out. So let's go ahead and see if this is a true answer, because I said that we can't have this negative, and it's true, but let's go ahead and plug it in and see if we actually get a negative value inside our log. So let's look at that real quick. 2 and our x value is negative 3/2 plus 7. These 2's are going to cancel out, so I'm really just left with negative 3 plus 7, which is just log base 8 of 4. So you see, I don't really get a negative number inside my log, or what I'm going to evaluate my log. So this is perfectly okay. This is a correct answer. Let's look at the last one, which is a challenge question. A challenge question for you homework peoples. The way we do this is you can actually knock this out with a log base 3, but as I said in class, I like to actually work with natural logs. It makes life easier. So let's go ahead and use natural logs to kind of estimate a value for this. If I use my power property, I can go ahead and rewrite this side of it as the natural log of 3, and my quantity of x plus 4 gets brought down. Same thing happens to this side. The quantity of 2x minus 5 gets brought down. Natural log of 6. So now you can go about this different ways. We still just want to isolate x or get x by itself. So I'm going to go ahead and divide the natural log of 3 to both sides. This ensures that that goes away and I'm left with x plus 4. I'm going to evaluate this number out to kind of make things simpler for me. Natural log of 6 divided by natural log of 3. So I get 2x minus 5 times the quantity of 1.63. Now I'm going to have to distribute this quantity to both these terms. When I do that, I get 3.26 x minus 1.63 times 5, 8.15. On this side, we just drop down the x plus 4. I'm going to go ahead and subtract an x here. If I subtract an x there, this goes away. I'm left with 4 is equal to 2.26, because I got rid of one x, or just one whole number, minus 8.15. I'm going to add 8.15 to both sides. This goes away. Bring in my x there. That goes away. And I'm left with 8, 9, 10, 11, 12. 12.15 is equal to 2.26x. Divide both sides by 2.26. So it's 12.15 divided by 2.26. Okay, so when we do that, this cancels. What you do to one side, you always have to do to the other side. You end up with 5.30, approximately 38. That's your answer. So I hope this helps, guys. That's a lot of work. If you need to see any one of these examples again, just go ahead and pause and replay as needed. Good luck, and I hope I've answered your questions. See you guys.